The broadcast is now starting. All attendees are in listen-only mode.
Aloha, everyone. Thanks for attending today's webinar hosted by the Western States Genetic Services Collaborative. Today's webinar is the third in our webinar series on whole genome and whole exome sequencing. It's my pleasure and honor to introduce today's speaker, Dr. Kevin Fitzgerald. Looking at Dr. Fitzgerald's CV, you will see no shortage of degrees following his name. He has a bachelor's degree from Cornell University, master's in divinity from the Jesuit School in Berkeley, California, and both his PhDs from Georgetown University, one in molecular biology and one in bioethics. He is currently on faculty at Georgetown University as the Dr. David P. Lauer Chair in Catholic Healthcare Ethics and Research Associate of Oncology. Our project director, Sylvia Mann, who sends her apologies for being unable to introduce Dr. Fitzgerald. But Sylvia first met Dr. Fitzgerald when they were both serving on the Secretary's Advisory Committee on Genetics, Health, and Society. The committee tackled many subjects, including gene patenting, direct-to-consumer genetic testing, genetics education, and large population genetic testing. As a molecular biologist and bioethicist, Dr. Fitzgerald was well-versed to discuss the potential ethical and social issues surrounding the complex topics that the committee was given. In that vein, today's presentation of the ethical and social issues of whole genome sequencing is timely for Dr. Fitzgerald to present, since it brings together many of the benefits and challenges that are similar to what the Secretary's Advisory Committee discussed throughout its existence. So before I hand it over, just a reminder to everyone to please mute your phones and your microphones to prevent any noise interference. And if you have any questions, please type them into the question box on your webinar panel, and Kevin will address these questions for you at the end. And with that said, I'll pass it over to Kevin. Thanks.
Thank you very much, Jennifer, and thank you to everybody who's listening and who will be listening. I just want to start, let me see here, by showing my screen. There we go. There. And then hopefully that did it.
Yes, we can see it.
Okay, great. All right, so I would just also like to start by acknowledging, I'm sure there are a lot of people who will be listening and are listening have a great diversity of backgrounds and expertises in this area. So really what I'd like to focus on today is the greater context within which whole genome sequencing and whole exome sequencing are being developed. And that is the idea of how do these fit into 21st century healthcare. And we're already aware of the fact that 21st century healthcare is supposed to be a time of personalized medicine, individualized healthcare. And this slide comes from an initiative that was started in September of 2007, as you can see, in the Department of HHS at the time when Sylvia and I were serving on the Secretary's Advisory Committee. And the idea here was to get people excited and to get people really anticipatory about what healthcare was going to become. It was going to become personalized in a way it hadn't been before, because we were going to take this area of genomics and integrate it with health information technology and clinical evidence and all the rest of this, and it was all going to come together to provide what you see in the bottom right-hand corner, the right treatment for the right person at the right time. Well, of course, this sounded all great and wonderful when they were rolling it out, but a couple of us were scratching our heads because we said, well, wait a minute. Has anybody ever gone to a doctor and expected something other than this? So what is it we're really promising people? What is it we're really saying we're going to give them? And I think the idea was, perhaps, in a sense, we were going to give them what we had always hoped to be giving them all the way along in healthcare, which was the right treatment for the right person at the right time. And the idea was that these new genetic technologies might help us do that. And there were a variety of ways that was going to happen. First of all, as you can see in the prologue from that same report, it was acknowledged that as the technology advanced, we were beginning to recognize the fact that there was a lag between the advancing technology and our advancing ability to contextualize it appropriately, so that our definitions of health and disease were stuck several centuries behind. And so in the traditional way, when we referred to asthma, right, we now had to acknowledge, well, there isn't just asthma. From a treatment perspective, you have to come at it from a variety of different angles. And more in my area, oncology, when we talked about colon cancer, really we were not talking about a disease, but just a place where a disease occurred, and that there might be several different types of colon cancer, at least 5 different major mutations that could drive different pathways that would lead to different treatments. And nowadays, and even in the near future, if one treated colon cancer all the same, that would actually be malpractice. So we're moving into a new era, and this era is supposed to not only allow us to understand health and disease better, but also improve treatment. And a way, of course, we could do that again was to sort of acknowledge a problem that had always been there, but hadn't really been put forward at the forefront of healthcare. And I think many people in the world outside of healthcare would have been sort of surprised to hear this. But the realities were that you would take a patient group, as you can see from this Nature article, and that patient group all would have the same diagnosis, and they would receive the same drug or treatment. And you would get 4 different results, only one of which was really desirable. And that was in the bottom right-hand corner, where the drug does not harm the person, but actually helps. Now, in a sort of perhaps hopeful way, this Nature diagram had the most people in that quadrant. But as we know now, that is not always the case. In fact, probably the largest quadrant is in the upper left, where the drugs that we give do have some toxicity, but we give them because we know or we hope that the benefits will certainly outweigh the harms that might be involved. But really what you want to do is avoid the other 2 groups, the upper right and the lower left. And the upper right, obviously, are the times when we actually end up doing more harm than good, and there are various names for that, iatrogenic disease or healthcare harms, whatever. This is particularly the group we want to use now our increasing genomic information to reduce the numbers of people in that group. And then the bottom left, well, that's very interesting, of course, because you don't want to be giving something that's really not doing much of anything except making money for somebody along the line. So that's a whole different ethical conundrum that is raised there. But the idea is, this is in part the hope, that using this information that we're going to develop with these new genetic and genomic technologies, we're going to be able to do a better job on all these levels. And in fact, as you are probably well aware, this is already underway. This is an article that came out, as you can see, in January, about 1.5 years ago, and the Mayo Clinic was already saying, look, this is moving beyond the research stage. We are getting to the point now where we're going to be treating patients. This is how we're going to use it. It's not just for research, but to help better personalize individual care. So the question here is, all right, can this technology do that? And what do we mean when we talk about individualized healthcare? Because I think there's a huge assumption there that in gathering this information together and pulling together all this data, it's just going to become clear what options we should pursue when we have to make decisions about individual healthcare. But that might not always be the case. Now here is a picture of a group. I love this picture. Look at that group of people. I mean, they are just happy, smiling. They look like they're just having a good time. And my guess is they are, because they are all together in a community down in Ecuador. And they are a group of descendants of Sephardic Jews that came from the Iberian Peninsula and brought with them a founder mutation. And that founder mutation leads to a condition known as Laron syndrome. And a particular researcher, the gentleman here in the back, as you can tell because he is much taller than the rest, went to this community with the intent of saying, how can we use our genetic and genomic technologies to perhaps help these people? And of course, as you can see, they're obviously in need of help because they're short. I think some of the tallest members of the community in this group are about 4'8". And of course, they have other health care challenges. But the question is, who's helping whom? And this was one of the articles that came out of this research, published in Science Translational Medicine. As you can see, it's already 2 years old. And this was the researcher, Jaime Guevara Aguirre, and others who were down there. And the fascinating thing was, yes, they did identify the mutation, and mutation is in growth hormone receptor, and it leads to, obviously, severe reduction in height, and also a down regulation of the insulin growth factor 1 pathway. And so, of course, that does lead to the shorter stature, but it also had 2 other results that were rather surprising. And if you notice at the end of this little abstract here, the individuals with Laron syndrome and other growth hormone receptor deficiencies don't get cancer. And they don't get diabetes. In contrast to a normal prevalence of 17% for cancer and 5% of diabetes in control subjects from that area. This raises a very interesting question. Who are the healthy people? Who are the healthy people in this picture? Is this person at risk for cancer and for type 2 diabetes? Who should be studying whom? Who should be helping whom? I mean, I work in an oncology department. I work at the Lombardi Cancer Center. Cancer and type 2 diabetes are 2 of the big healthcare scourges in the 21st century. So would we be helping these people if we actually were able to go in and say, not only for them, but perhaps for their offspring, say, don't worry, we're going to correct your deleterious mutation so that you, like us, can get cancer and type 2 diabetes. Well, of course, this led to other research, which many surprises like this do, and some people thought, well, wait a minute, maybe there might be a way we can take advantage of this understanding, this new insight, and maybe find a way to get both the height and normal health that we consider is average for ourselves, and this new way perhaps of avoiding cancer and type 2 diabetes. And as you can also see, they have reduced prevalence rates of acne. So a little extra benefit thrown in. And of course, in looking at this down regulation of the insulin growth factor signaling pathway, it was acknowledged that, well, one of the things that may be leading to our increased risk for type 2 diabetes and cancer and other problems is our very diet, the Western diet. Now, of course, one could say, well, then fine. Let's look at times and places in human history where other diets were prevalent, and perhaps cancer and type 2 diabetes were not. And of course, one of the things that's often being recommended is to try a radically less insulinotropic diet like the Paleolithic diet. And of course, Paleolithic is a word from anthropology that means old Stone Age. And that was quite a while ago. And of course, then you might ask yourself, well, what exactly is the Paleolithic diet? Well, it turns out there's not necessarily a particular specific description or definition, but as I got off this website that talks about Paleolithic caveman diets, it's quite interesting. Of course, by today's standards, as you can imagine, it's very restricted. I think it's about half the calories or maybe less than normally are consumed by people in the United States, and most of the foods that we eat would not be obviously available to Paleolithic people. So one way of sort of summarizing this is, sure, here's a solution to increased risks of cancer and type 2 diabetes. Eat like a caveman, and of course exercise like one too. So obviously, as a practical option in healthcare, this may not necessarily be a good one to pursue. But it does raise the question, what are the real goals of healthcare? And what are the real goals of all this genomic research we're doing? Will it be that we're going to come up with these magic bullets, or is it much more likely that we're going to come up with a situation like we saw with the people with Laron syndrome? The one that we see practically every day if one is willing to be rather precise about one's evaluations of people's health. Everybody has advantages and everybody has disadvantages in their genomic and epigenomic makeup. Question is, who's healthy? How do we start delineating genomic good health? Who are the people we're going to look to and say, oh, that's what we're working toward? These are the people for whom all should be oriented in their health. Because we know there are a lot of different ways of looking at this situation. And here in Washington, D.C., we have a particularly poignant example of this. We have a sister university across town, and their name of the university is Gallaudet University. And it is a university that is known to attract students who are deaf or are reduced in their hearing abilities to the point where they, for all practical purposes, are the same as being deaf, completely deaf. And of course, their argument is they're perfectly fine. They're not sick. They're different. And I don't want to pretend to say that that's a homogeneous position taken by all members of the deaf community. But it is an argument that comes out of that community that, again, raises this very interesting question. One which I'm going to say is going to be exacerbated by our increasing use of genomic and genetic technologies. Because not only are we going to encounter an increased challenge with the areas that we know currently, like deafness, but there will be surprises, like the people with Laron syndrome, and there will also be surprises in other areas where we might see possibilities for treatment and intervention where we had not before. And so recently, there have been some papers that have come out and announcements that have been made about the possibility of using siRNA, silencing RNA technologies, to treat chromosomal abnormalities such as Down syndrome. If you have an extra chromosome 21, and the vast majority of the quote-unquote healthcare problems of people with Down syndrome come from an overexpression of certain genes on chromosome 21, which seem to be logical that one would look to these silencing RNA technologies as potential treatment to reduce those overexpressed genes and bring the people with Down syndrome back to normal. Now, interestingly, again, similar in part to the deaf community, the community of families who have members who have Down syndrome responded in a mixed way to this announcement. You can go on the various blogs and take a look for yourself. There were some people who were very excited about the possibility of doing something that would, again, help their family member. But there were many others who responded and said, wait a minute, why would I want to change my child? My child is perfect. I love my child just the way he or she is. And so we're going to, I think, encounter more and more this tension. What is health? What is healthcare? And I think that tension is going to be increased by this increasing use of genomic and genetic technologies. And it may hit home in ways, again, too, that we do not anticipate. And this I can certainly attest to from a personal level. I don't know if any of you had had the opportunity to go online and Google any images of me, but if you did and you saw certain ones, you would see that I am a member of this particular mutant community, redheads. And recently, they have identified a gene that we have mutated, the MC1R or 1C1 receptor gene, which has been found to bind to PTEN, P-T-E-N, many of you are familiar with, as a tumor suppressor gene. And this turns out to be probably the genetic cause for why we redheads can spend 15 minutes on the beach in Hawaii and engender multiple melanomas, while many of you might be able to enjoy that marvelous locale for a lot longer than those of us who are in this redheaded community. But the point here is, do I want genetic engineering to change? Is it important in that sense? Not just, again, for me, but perhaps for a public health benefit? Is that often not the argument that is being made? That, well, some of these treatments should be pursued because it would reduce the disease burden, right, of the community, the society, the country, the world. And one could make an argument, I suppose, that redheads should all be genetically engineered, or in the future engineered not to have this mutation, and that might actually cut into some of the melanoma risks, because I think we do have a lot higher than most others. And now we don't make up much of the population, but then neither do many of these other disease communities. So here's the question. How do we go out to the public bringing these technologies, which I think, as we can see, and perhaps many of you have already begun to experience in your practices, are going to raise many, many more questions and many, many more challenges than perhaps provide treatments, solutions, and answers, certainly in the short term. How do we bring this to public and, at the one hand, attempt to continue the pursuit of the benefits that are there, at least theoretically, for personalized medicine, and at the same time honestly and openly address some of these issues that are raised in terms of the diversity of the human condition. We are all different. We all have our deleterious genes, and we all have ones perhaps we're really desirous of. And so how do we begin to sort out that process? And I think in part, one, certainly in healthcare, is going to say, well, the focus is going to be on the patient's good. Well, the question then again arises, what is the patient's good? And is it up to the patient alone to decide what his or her good should be? Because certainly if these technologies can add a vast amount of information to our understanding, they'll also probably add the possibility of using some of that information to manipulate things, genes, gene expression, to a particular end that a patient may desire, even if that end might not be considered to be normal for healthcare. So a person saying, well, I want to be a redhead, and I don't want to just use dye for my hair, I want to really be a redhead. Would that be a good thing? So these are the kinds of things, and again, this is nothing new in terms of, say, the deafness community, because that has already been addressed many times in terms of requests for having children who would be deaf in terms of their own genetics. So this isn't new in one sense, but as I'm trying to say, I think we are going to gain more and more attention to this and more challenge in this area. So it raises a variety of ethical issues. Here are just a list of a few. Again, when we talk about personalized healthcare, individualized medicine, whole genome sequencing, what's the goal? Now, we often tout it as the goal is better health, better individualized care. But really, can we promise that? And what do we mean by better health? Well, certainly we argue that we're going to get more knowledge out of this, and from more knowledge we'll be able to do more things. But is that true? I mean, some of this knowledge is going to be actually knowledge that's going to tell us what we cannot do, or that what we thought we could do we won't be able to do. Well, we certainly will get more data. But is getting more data going to add to patient value? Because many times I think when we are talking about this, and certainly in discussions that I have had with healthcare systems and other institutions in healthcare, one of the things you have to acknowledge, especially if you pursue research or treatment in this area, is we can't even predict what we're going to discover. We don't know what we're going to find out. So there will be surprises like the Laron syndrome surprise, but there'll be other surprises too. We'll be finding out that things that we thought were good might not necessarily be as good as we thought. What will we do with that information? And what will we do with information that is just unexpected, not in terms of we don't know about it, but unexpected is that we didn't know it was there, what we call incidental findings. How free will the patient be to not know if the information is supposed to be generated to provide better health care? And if that better health care is supposed to be comprehensive, and it's supposed to be integrated, and it's supposed to be something that takes, as we say, all this information and puts it together in a way to allow us to do more individualized treatment, aren't all findings going to be relevant? And not just relevant to that individual patient, but relevant to that patient's relatives. So if we talk about the option or the possibility of somebody saying, well, I just don't want to know this, or I don't want to know that, or I don't want my relatives to know this or that, can we do that without causing harm? Does that not reduce the availability and the potency of using this genomic medicine to do what it's supposed to do? And again, with all this uncertainty in there, how do we balance these risk-benefit ratios? What do we do with all that ambiguity? Well, again, as I know, many of you already deal with that in your current practice. My concern is this gets ramped up very quickly and in a way that perhaps we are not as prepared for as we need to be. And of course, one of the ways we hear all the time, especially with genomic medicine and genetics, is this idea of confidentiality. All right, fine, the patient wants to know, and maybe the patient's family and all, that's all great, but they don't want everybody else to know. So what kind of confidentiality is going to be out there as possible when you consider what has to go into these databases, what will be present in publications, and the extensive nature some biorepositories are being proposed to cover? Well, again, this is not new. We were wrestling with this on the Secretary's Advisory Committee, Sylvia Mann and myself. And obviously we're not the only ones. This is from the Presidential Commission for the Study of Bioethical Issues, which is the current iteration of these committees that different presidents appoint. And they, of course, too, wanted to take a look at this issue. And this comes from their report, which I believe you had access to. And if you glance through it, it does present an attempt to create somewhat of a balance, or one might perhaps say more accurately, a constructive tension. Okay, so on the one hand, they want to say, look, this has already worked. Researchers have already been able to help, right, some children born with rare birth defects by sequencing and analyzing their whole genomes. I believe there was a case in Kansas City where a child was not thriving, and the researchers and the clinicians had no idea what was wrong because everything they tried wasn't working, and they finally decided, let's just sequence the genome. Lo and behold, they found something they had not expected, were able to create a treatment out of that, and it worked. Also, the idea of personalized medicine, including predicting an individual's risk for a heart attack, or what's the best dosage of the medication for that individual. That we already know in pharmacogenomics is out there. And of course, now we have the entire area of fetal whole genome sequencing, where the sample can be taken from the mother. It's not an invasive protocol anymore. And that innovation, I can tell you, is already starting to reach the clinic. So this is, as they say, the beginning of an era. And they say this era has the potential to revolutionize medicine. Well, I don't know if you did, but when I saw that wording, it struck me as extremely poignant. It may, in fact, revolutionize medicine. And, of course, recently we are all too painfully aware of exactly what happens in revolutions. There's a lot of good that's done, but there's also the potential for a lot of harm. So the question here is, if we're going to revolutionize medicine, can we really work to create and bolster the goods while avoiding some of the harms? Now, of course, their way of approaching this, and they lay this all right out, and this is important to always look at when you're looking at the reasoning behind why a group or an institution or a nation in policy decides to do one thing and not something else. All right, so again, laws and regulations cannot do all the work necessary, so there have to be other ways of looking at it. Ethics is certainly one. This commission, before in an earlier report, thought that they would focus on what they called 5 ethical principles. And we can debate whether or not they're all really principles, but anyway, these are the 5 focal areas that they want to address in determining what might be good and what might not be good for applying whole genome sequencing technologies. So you can see them right here. There's the public good, responsible stewardship, intellectual freedom and responsibility, which is a very interesting juxtaposition, democratic deliberation, and justice and fairness. Now, any of you who have studied ethics knows justice is a very loaded term, so I think when they matched justice and fairness, here they were talking mostly about what we call distributive justice. In other words, is the good being made accessible to as many people as possible? There are many other areas of justice, but they didn't necessarily want to get into those. So these are the areas they're focusing on. And they want to take these principles and the principles set forth in the Belmont Report. So those would be the ones you've heard about before, often called the Georgetown Mantra. So you have autonomy, beneficence, non-maleficence, and justice. So individual respect, doing the good, avoiding the harm, and of course that marvelous grab bag justice. So what they wanted to do in this report is to focus on recommendations using these principles, which would allow for the pursuing and securing of public benefits that, of course, we're talking about from whole genome sequencing, and again, minimizing the harms. The question is, how do you get there? So, of course, one of the things we talked about, and they talk about, is this idea of privacy and confidentiality. How does one go about protecting and respecting and fostering privacy and confidentiality? So they broke it down into what they call 3 different facets. The first facet, of course, is the idea of the individual privacy and confidentiality, and as they kind of focused in on it, this requires fostering ethical behavior norms for researchers and clinicians. Now that's very interesting. So in order to address the individual, it's the healthcare professionals and the researchers that have to be trained. So we're the ones who are responsible for this. And what is that going to entail? How do we do that now? Do we do it well enough? And I would argue probably not, considering the challenges that are coming forward. And if not, then how would we go forward in that realm? That, I would say, is not going to be necessarily the easiest thing to pursue, but it's certainly going to be very important. The second fact that they talk on, the second facet, is privacy protection in information technology. Okay, so what does that mean ultimately? Basically, there's a need for fundamental trust in the ethical behavior, again, behavior of data users. So again, these people now are going to have to be trained. how to use this how to use this data ethically. But even beyond that, the security of the systems that store these data. So now I am not a computer expert. I am not an information expert. I certainly have had some conversations with people in that area, and my understanding is this, and of course we've certainly heard about this recently with everything that's been going on with the NSA and all the other issues about computer and internet security. This is not absolutely possible. So what you do is you get more or less security, better or worse, but there's nothing out there that is absolutely secure. So that too needs to be made clear to the public if indeed these are important areas of concern. There are just some things that are not going to be able to be done perfectly, absolutely, but only to a certain extent. And that brings up the third facet of privacy policy, of privacy protection, and that is the policy. And policy also raises some interesting issues, and this facet itself is divided into three. So again, sort of reiterating what you heard in the first two, expectations of training and preparation. So the people who are doing this are going to have to be trained well. How do you define well? Well, that's a good question. That will be very interesting to see how that goes forward. Why do they have to be trained well? We have to ensure an atmosphere of trust and an expectation of security. Right? So at least we're going to work hard in these areas in order to engender public trust. And then finally, again, this is well outside of my area, but will lead to, I'm sure, very many interesting legal discussions, have to provide recourse should individual and informational technology privacy protections fail. In other words, what are the punitive measures going to be? What are the reimbursement measures going to be? What are the other measures going to be legally, because that's how our system works, to attempt to provide some kind of balance in terms of a threat, in terms of a punishment, in terms of inducements and enticements to do these things as well as possible. And what are the standards going to be that people will be judged by and perhaps prosecuted according to? Because there is a problem. As I mentioned, I talked to security experts who have told me this is not possible, but this, I have to say, this article, if any of you saw this, this was quite a revelation when this came out. This was a group of people, mostly information technology and computer people, who thought it might be interesting to see just how much data is already out there. And you can go back and look at the article itself. It gets a little technical at times, but basically what they did was they took genomic information by short tandem repeats on a Y chromosome, and they took the information found in recreational genetic genealogy databases. Again, remember, everything they used is on free, publicly accessible internet resources. They did not have to do anything but just go on the internet and find all this stuff. And then when they took that and they combined it with other data such as surnames, age and state, other sorts of things like that, they were able to quantitatively analyze the probability of identification for U.S. males. And they furthermore, and this is really amazing, demonstrated the feasibility of tracing back with high probability the identities of multiple participants in public sequencing projects. Now, it wasn't just me who obviously was taken aback by this, but the people at NHGRI certainly were. Here's Eric Green, the director, and other members of NHGRI. And this came out, I believe, in the same journal article, not article, same issue. And they acknowledged the authors were able to establish the identity of close to 50 participants in the CEPH project, women as well as men. So even though it's done from short tandem repeats on the Y, that doesn't mean you can't extend that to other information. And of course, they did not reveal the names of the participants or violate any policies, but they did demonstrate the ability to do that. So what was the response of the people at NHGRI? It is now time for the research community to engage in a rigorous and open discussion about data identifiability and how to balance most effectively the benefits of broad data sharing and the imperative to respect and protect research participants. Okay? So let's just go back for a second. This is 2013. The President's report came out in October 2012, which basically said the same thing. So it's sort of like people are now starting to wake up to this. And interestingly, again, it was acknowledged who's going to be in this rigorous and open discussion. This dialogue should involve a full range of stakeholders. So basically everybody. Everybody needs to be involved. We all have to sit down and say, where are we going with this? And what is it we really say we want from it? And again, following up on this was a memorandum from John Holdren's office, the Office of Science and Technology Policy, and this was for all government departments and agencies or executive department agencies, and this was what their response was. So again, an attempt to balance or perhaps provide a constructive tension regarding, right, how we're going to maximize access on the one hand and protect confidentiality and personal privacy. Again, as you notice here, it's just you shall plan to do this. No answers on how you're going to do this. Well, there are a variety of ways in which people are attempting to come up with protocols and procedures. One comes from this article, as you can see here, was in PLOS Biology about a year ago, and this was looking at biorepositories and informed consent. And you're probably all well aware of the various options that are being put forward, oftentimes grouped into two different categories. The opt-out category, which of course says you have to yourself go through some procedure to pull yourself out of these programs. They will be national, social, inclusive programs, and you will have to then intentionally opt out. And of course, you can see here the list of advantages that comes from an opt-out approach. You know, scientifically, obviously, you're going to have higher participation rates. You'll have lower costs, right? There'll be a moral duty to participate. This is a very interesting argument. Again, goes back to that public health argument that people, if they're going to benefit from the health care of a nation, they have a duty to participate. You have low risks and burdens in terms of additional physical burdens and risks. Everybody's involved. It is, in a sense, compatible with autonomy if you make it a thick opt-out procedure. And this would, of course, be something very different than our current newborn screening opt-out procedures. This would be something where people would have to very rigorously and robustly be engaged to make sure that they know that they're in this and that they do have an opportunity not to do it. And then again, there might be the idea of a public attitude that would be positive toward the research since everybody's involved. Now, of course, on the other side, plugging creative tensions here, or constructive tension, is the opt-out approach. And again, here you also are respecting autonomy, but it's a different way. You're respecting an individual's ability and power to choose for him or herself, because they have to choose to come in, right? It's not that they'll automatically be included. They have to agree to be included. And so in this way, it fosters this autonomy. It also might foster, in a sense, less participation, but a group that's very engaged, which would be a scientific citizenship. Which again, all these things have to be weighed one against the other. And here, of course, there's a nice protection talking about liabilities and possibility of punitive punishment. This protects the researcher. You can always go back to the person and say, look, we warned you, you signed up. And again, there'd be public trust because the only people involved are the people who signed up for it. But I give you this just to give you a sense of some of the back and forth that's going on currently in ethics right now about these topics. And again, This is being touted as so important because of all the possibilities and the benefits that are going to be brought forward by using these technologies. And this, I love this article in Nature. It's some big names in genomics research, and the idea that now we're finally going to be able to take what has been primarily beneficial to the first world and perhaps bring it to others who have not been as engaged before. And if you'll notice here, these are all members of various indigenous communities. This is a member in South Africa of a Click tribe. This is a Tibetan. This woman is from the Andes. And this is an Aborigine child from Australia. So these are all identified indigenous communities. And we are now going to reach out to those communities and through this genomic technology bring them in. Why? Because they have some of the most interesting genomes in the world. They have been marginalized from main society, so their genomes are actually more different than anybody else's. So there's also a scientific reason we want to reach out to these groups, because they might have some information similar to that group in Ecuador, the Laron syndrome group, that we can't get any other way, or not as easily. But how are we going to do this? Okay, many of you are probably already, whoops, sorry about that. Many of you are already aware of the Havasupai case in Arizona State University and the tribe from the Grand Canyon, and the idea that, again, a researcher reached out to this group. She was already engaged with the population. They knew her, and she wanted to, again, bring to them the benefits, potential benefits of genetic and genomic technology. Of course, you may be aware that it all didn't work out the way either side expected. And in fact, if you're interested, there's a blog going on right now. I believe it's coming out of University of Albany up in New York. And it's fascinating to see the people continuing to argue about this case. Who's to blame, who's not to blame, who did something wrong, who didn't do something wrong. But here's my question. Did either side get what they hoped for when they entered into the agreement? And I think clearly the answer there is no. And so I'm not as worried about who's to blame and who's not. I mean, yes, that will be part of the legal recourse, which, as you notice, is what happened here. I mean, it in the end went to a legal resolution. Is that what we want? Is that how we want genomics and genetics to go forward? Is this the desired outcome? I would argue, hopefully not. And then the question is, well, if this isn't it, how can or how might we go forward so we can avoid this? So what I'd like to do in the last few minutes here is just talk to you about a little project we did here at Georgetown. And of course, talking about our own project at Georgetown is all about self-promotion. So I just want you to know that it wasn't just us who thought this was a good idea. This came from Rod McInnes's presidential address, ASGH. And he, of course, is from Canada and has done a lot of work with indigenous populations. And in his talk, he mentioned this very question, which way is the way forward? And he very much enjoyed our article, which we thought was great, which was published in the Journal of Law, Medicine, and Ethics. And the idea here is because we did recognize the fact that Canada and Mexico were way ahead of us in this regard. How do you reach out to vulnerable populations, particularly indigenous communities as representative of those? But one could include the deaf community, the Downs community. I don't think the redheads have a community yet. We've got to work on that. But all these different groups. And everybody's going to end up in a vulnerable community of one sense or another, as far as the fact that we're all genetically vulnerable. How do we go about doing this, focusing on those who currently are most vulnerable? Well, this was our little event, and it was, as you can see, partially funded by the Department of Health and Human Services. And we engaged with them in this, and basically what we did was invite people from around the world representing different indigenous communities and asked a very simple question. Would you be interested in being involved in genomics research as a community, engaging with us in your community's involvement in this. And I have to tell you, the most surprising part of this entire colloquium was their initial response, which was across the board, yes, we do want to be involved. We do think it's a good thing. And of course, at that point we asked many of them, why? After what has happened to you, after your experience with biomedical research and pharmaceutical research and all that, why would you want to do this? Especially taking into consideration the great healthcare needs you have already. How is this going to help you? And their response was, yes, we have great healthcare needs. We need clean water and sanitation and antibiotics, nutritious foods, healthy diets, all that. But we're going to get that. And once we have that in 20 years, we don't want to be 20 years behind on the genomics curve. We want to be involved in genomics research now so that we will get the benefits as they come out. And, oh, by the way, we'll be able to tell you what some of those benefits will be, not have you tell us. And so these were the 4 recommendations that they gave to us, which came out of our meeting. And again, in some senses, not very surprising, but in other senses, stuff that we didn't necessarily think of on our own, which again is why it's important that this discussion be very broad-based. So as they said, you know, don't come in thinking that you're going to sell us something. Do it like this. Ask us, just like any of us would want to be asked to be part of some kind of research program. Go in and ask them. Secondly, don't think we have the way to go about it. Because again, we look at these things mostly from our Western individualistic perspective, which says informed consent is done with the autonomous individual, as you saw in all our documents and the things that I showed you today. Well, most of the world doesn't operate that way. Most of the world is more on a community-based decision-making platform. And so they would say we need some community-based processes in IRBs. Many of you may be familiar with the Navajo tribe processes and others that have been developed. But it's just that insight that it may need to be a hybrid, may need to be both individual and community in order to do this well. Thirdly, they asked the question, when you come to us, why is it there aren't members of our tribe or group already in your research community? And of course, we're all well aware of the fact that it's difficult to get the minorities into these research careers, but perhaps part of that was the fact that they weren't the ones directing the projects for how to get them in. We were. But now some of that is being addressed, and so I think there's a great deal more hope there. Then, of course, in the meantime, while we're trying to integrate them more and more into our research communities, training our scientists in how to work with indigenous and developing communities. Training scientists and researchers in cultural sensitivity and in ethics and in all these different things that we've been talking about. And of course, as a practicing bench scientist, I can certainly tell you with great emphasis that scientists aren't going to want to do this, right? We're too busy writing grants. We haven't got time to do this. It's already stretched to the limits. I haven't got extra time to do all this extra education and training. Well, if you want to do this research, I think that's the way it's going to have to be done. But perhaps a better answer would be to say, how can we integrate that training now into our undergraduate and graduate programs? So it isn't something that has to come in later in some kind of extraneous or additional tangential way, which is sort of like how the NIH and NSF put the extra little boilerplate section in their grant proposals looking at ethical issues. You know, suddenly there was a new section, ethical issues, and everybody was running around asking us for boilerplate language so they could stick it in their grant proposals. So I think where we come to in the end is that there is much whole genome sequencing, whole exome sequencing, and all these genomic genetic technologies can bring. The question is, what of it will be good, what of it will be problematic, and what of it will be just what we make of it? And that will require this more broad discussion. We will have to have input from a variety of stakeholders, and I think just about as broad as we can get. And we will have to discuss the very fundamental goods and goals of whole genome sequencing. Those of us involved in genetics may say, oh my gosh, all the information is good, as you want as much as possible and dump it in the databases. We may find out that other people don't think that is the case. And even when they come to understand the technology better, they still may not think that that's the case. So we have to be prepared in this discussion to hear things that are going to be very challenging to us, and to be open to listening to why others may see things very differently than we do, especially the people who have and are been the most vulnerable in these areas. Will this slow technological progress? Well, I should probably change this. I don't think it may be slowed. It will be slowed. But then what's the goal here? Is the goal technological progress, or is the goal better health care? So I leave you with that, and I very much look forward to any questions and comments you might have. Thank you very much.
Thanks so much, Kevin. Actually, we haven't had any questions come in. Do you have anything else you'd like to add?
Oh, well, okay, so a couple of different things, if I still have some time. What I would also argue is that we, as a group of people involved in genetics in healthcare, are also not homogeneous. We too need to recognize that there are a variety of perspectives, areas of expertise, and also needs and desires that are different. And I think that balance also would be one that would be good to even start to engender within the genetics community. So I would think that we could even model some of what might need to happen for the larger society within our own community. And by doing that, we might be able to work out certain protocols that seem to be more efficacious and streamlined than others. But that, again, is something that we just have to get that conversation going on and see where we go with that. And I'm not exactly sure yet exactly which organizations or institutions would be best for that. As you may be well aware, the Secretary's Advisory Committee on Genetics, Health, and Society was shut down a couple of years ago. Dr. Collins came in and told us we had done our job marvelously well and we weren't needed anymore. Which, of course, some of us who were involved with the committee and still connected to it at that time were thinking, I'm not so sure if that's true, but okay, that was the assessment. But in any case, I thank you for your attention, and I look forward to any input you might have, either now or in the future. You could certainly email me with any questions or insights or any offerings that you might have. I would be very happy to hear them. So thank you again.
Yeah, thank you so much, Kevin. If anybody does have any questions or wants to email Kevin, you can email us, myself, Jennifer, at hawaiigenetics.org, and I'll get it over to Kevin. Thank you so much, Kevin.
Thank you very much.